Neuroeconomics combines behavioral economics and neuroimaging to study the way that people make decisions. We use functional magnetic resonance imaging, which you can think of as time-lapse photography of the brain's activity while people are making these choices. And I was originally reading neuroeconomics papers for fun, which is a totally normal thing for people to do. And as I was reading, I was struck by, they were all about things like how do we allocate scarce resources, how do we make trade-offs between short-term benefits and long-term gains, or between moral and economic values. And these were all things that were readily applicable to environmental challenges that we face today. I looked around, this was in 2009, and no one really seemed to be looking at environmental issues through this lens of neuroeconomics. And I wondered why, and so that led me to applying to E-IPER with that premise, E-IPER, and sorry guys. And so this is the dissertation overview. Basically, we'll be talking about two different studies here today. The first one is on environmental valuation, how people value natural resources and public goods. And then moving to private goods, how people make decisions around energy-efficient purchases. We're going to be focusing mainly on the neuroimaging studies that form two chapters of the work. So a lot of you have probably seen by now these things that look rather like heat maps of the brain's activity. What we're actually looking at is called the bold signal, or how the brain shuttles around blood and oxygen in order to meet the energy demands of brain activity. And we're looking at contrasts for the given factors of interest. So say we were looking at how the brain behaves when price increases, then you'd be looking at correlated brain activity as price rises. And you can see down at the bottom there, z-scores, so statistical significance increases as you get towards a brighter and brighter yellow on these maps. We do this scanning in the basement of the psych building down at the CNI. And so someone lays down in that table by the MRI machine that you see on the left, and they put on a headset, and they see a computer program reflected in front of them, and they interact with the computer program that we've built to make decisions, and we record their responses and record their brain activity while they're doing that. So why use neuroeconomics? What do we actually gain from this window into the mind? So this gives us a really good way of seeing how people systematically diverge from what economists think of as rational actor behavior. There's all these ways that we do predictably irrational things that are well characterized, but maybe the underlying mechanisms of why we do certain things that are systematically irrational is less well understood. And we can understand when these divergences happen, what are the conditions that might predispose people to certain courses of action. And maybe one of the most interesting things that we can look at is assessing differences in the way that different types of people parse information, looking at things like their environmental attitudes or different aspects of their cognition, like how good they are at math. And so we're going to be breaking down people along those lines as well. There's two main ways that we can kind of break apart the brain imaging data. One way that a lot of people do for these studies is essentially correlational. So you're looking at what brain activity is associated with the types of information that you're presenting to people and what changes when you vary those attributes of the information that you're presenting to people. And we call this an input model. We're looking at how the stimuli affect the brain activity. But we also like to move one step forward into prediction and trying to predict behavior using people's brain activity. So we're looking at what activity is significantly influencing that decision making. And the most interesting areas to look at, especially when we're talking about environmental behavior change, is studying this overlap. So what are areas which not only respond to the types of input that we're feeding people and can be changed by framing effects and that sort of thing, but also those same areas being predictive of choice. And these are the target areas that we really want to delve into. It's been really exciting just in the last few years. There have been a lot of strides forward in using brain activity to predict not just the behavior of the people that are in your study sample, but at the population level. And this has been done in everything from music sales, the efficacy of anti-smoking ad campaigns, and the success of microloan funding. And the really cool thing is that this often can outperform the self-report of the people that are in those studies. So what do I mean by this? I'll give you the example of the music sales. So they had people listen to a bunch of hooks from music from unsigned artists on MySpace in around 2006 and rate how much they liked those different songs. Then they waited a few years and then looked at the music sales data nationwide on how those songs actually did. And brain activity in a part of the brain that we're going to be talking about in a moment, part of the brain's reward pathway called the nucleus accumbens, predicted how well those songs would do at a population level, but the people's conscious ratings of how much they liked those songs were not predictive of how the population was responding. So this offers special insight in instances when self-report might not be that reliable, which leads us to our first study. So how do we value the environment? How do we put a price on nature? And this is a very contentious question because a lot of the time, we're looking at moral and economic trade-offs when we're trying to ask people to assign dollar values to those natural resources. Environmental economists use surveys called contingent valuation surveys to try to elicit this, essentially asking people their willingness to pay to protect or restore a natural resource that's under threat. They first used this most prominently after the Exxon Valdez oil spill. But there's a number of problems with contingent valuation. One is incentive compatibility. So people don't actually pay what they're saying they're willing to pay. It's just a hypothetical question. And so they can throw out any number. And then a lot of people give protest zeros. So they say something to the effect of, you can't put a price on that, it's invaluable, and they refuse to answer. And this can be, depending on the study, anywhere from 30 to 50% of the responses that they receive. And these are summarily thrown out before analysis. And this is a problem because you're throwing out a lot of the, probably the people that value nature the most, right? They just can't assign a dollar value. So this is an instance where self-report is not that reliable, and brain data might offer some insight. The third point that I want to make that environmental economists noted when they were doing these surveys was that people really seemed to be queuing to the land use that was happening that was hurting that environment, so being overly focused on something like how they felt about the oil spill rather than the place that was compromised. And so they were basing their willingness to pay on, not on the natural resource itself, but on the circumstances that happened to it. This led Daniel Kahneman to comment on this and call it an example of affective emotion, or affective valuation. For our purposes today, affect we can think of as emotion. So he was saying, this captures attitude expressions, but not people's actual economic preferences. So this motivated us to ask, can we see the role of emotion in environmental valuation in the brain? Do these destructive actions of these third parties actually matter more than the natural resource itself in determining this willingness to pay? And can we predict behavior using brain data? Can we do better? Can we provide a complementary method that offers some new insight into these outstanding questions? So we did a behavioral survey before this that the results are the same as in the neuroimaging. I'm going to focus on the neuroimaging study. 20 subjects were endowed with $24 each. They saw a series of 24 different parks and proposed land uses. We had gotten a separate sample of people to rate these parks in terms of how iconic or archetypal they thought those parks were, and rate the land uses on how destructive they thought those land uses were. And they saw a series of 72 different trials like this where we asked them, do you want to donate to protect this park from this proposed new land use that's going to take a quarter of the land? And if we picked one trial to randomly count for real, and if people donated on that trial, then we took the money out of their endowment and gave it to their choice of the California State Parks Foundation or the national parks. We wanted to use parks in this instance because at the time that we started the study, the California state parks were under a lot of pressure. There was budgetary crisis where over a quarter of the parks were scheduled for closure. This is one of the hit you over the head examples of what people would see when they're in the scanner. Basically, they see a place like Yosemite. They see a proposed land use for a quarter of that park. And then they see the amount that we're asking them to donate out of their endowment. And they can choose yes or no. So what actually happened in the brain? To understand that, we're briefly going to go over how psychologists and neuroscientists think about emotion. And so the way they think about affect, a lot of times it's commonly mapped on this two-dimensional axis. One axis is valence, so how positive or negative the emotions that you're feeling are. And the other is arousal, how strongly you're feeling those emotions. And relevant to brain imaging, we're going to really focus on positive arousal, so strong positive emotions, and negative arousal being strong negative emotions. And these are associated with approach behaviors, things that you want to obtain, or avoidance behaviors, things that you want to get away from, respectively. And through meta-analyses and a lot of different studies, we know generally where these take place in the brain, where they're represented best. For the positive arousal, we look to an area of the brain called the striatum, particularly a subregion called the nucleus accumbens. It's there in kind of that yellow color. And for negative arousal, we look at the anterior insula, which is represented there in blue. And we'll loop back to those in just a moment. This affective information is integrated in a part of the brain that also handles how you form value calculations and calculate subjective value. And that's in the MPFC, which is in this kind of region up front here. So what happened when people saw iconic parks? It elevated activity in this positive arousal region, particularly the nucleus accumbens. It's an area that's often predictive of behavior, and in charitable giving studies, it's often associated with that warm glow of giving that people feel when they're donating, when they're helping people out. The striatum's at the core of the brain's reward pathway, so called because it responds to all the good things in life. It'll respond to food, sex, drugs, rock and roll. All that stuff falls into how the striatum is responding. And so the important part here, though, is that unlike a lot of other charitable giving studies, nucleus accumbens was not predictive of behavior in this study. What was predictive of behavior was actually negative arousal response. So what happened when people saw destructive land uses? So people donated significantly more often if they saw destructive land use, and they also donated significantly more often if they saw even a conservative use in a park that they felt was iconic. And this was associated with the amount of negative arousal people were feeling, and negative arousal was mediating the relationship between people's destructive land use impacting their donation behavior. So all of the bar graphs that you see today, the error bars are going to be standard error measurements. What was associated with this was we also saw more anterior insula activity when people were seeing these destructive land uses. And there's an area that responds to both physiologically and morally aversive stimuli. And this positively predicted decision to donate. So the more anterior insula activity that people had, the more likely they were to donate to protect the parks. Moreover, we saw an individual difference. When we looked at, we took ratings of everybody's pro-environmental attitudes using Dunlap's revised NEP scale. And so people who were more pro-environmental actually had much stronger anterior insula activation when they saw these destructive land uses. And this was actually the only difference that we saw between the brains of people who were more or less pro-environmental. When people were integrating this information, viewing the scenario as a whole, this was associated with activity in the medial prefrontal cortex. So calculating subjective value also considers self-relevant information as opposed to information relevant to others a lot, evaluates trade-offs, and this activity actually predicted withholding donation for yourself. So it may have been that the MPFC was more active when people were calculating that they had high value for the amount of money they would keep if they didn't donate. So this is a logistic regression that basically just sums up what we were talking about in terms of the response to the anterior insula and medial prefrontal cortex and the impact on donations. We're going to be seeing more of these a little bit later on. Basically, we do these series of models where at first we just model the attributes of the behavioral stimuli and their role, and then the brain regions, and then the combination of both. So what did we learn? Environmental economists were right. People were responding to land use and not to the resource itself. Using cost-benefit assessment regions of the brain may predispose individuals to more selfish behavior, and this can be overridden by emotional responses. Now, this can be a takeaway for nonprofits and NGOs that maybe you don't want to throw vast amounts of data at people and get them into a cost-benefit analysis frame of mind when they're thinking about environmental decisions. If you want them to act, it may be better to leverage the emotions. And most importantly, for the next studies that we're going to talk about is that pro-environmental attitudes can translate into these visible differences in activity in brain regions that predict behavior. And this is a very positive finding for things like environmental education, where if you can get people's attitudes to change, you can even perceptibly visualize the impact of that attitude change in the brain and how it plays out in behavior. So we'll be moving on now to talking about energy efficiency decisions, going through a national survey that we did. This was in partnership with a colleague in the MS&E department, Ansuman Sahu. And we're looking at basically people's purchasing behavior around refrigerators and light bulbs. So residential energy usage accounts for about 20% of US energy consumption. And in an effort to make people a little bit more efficient, the EPA made the Energy Star certification program to kind of draw attention to goods that were energy efficient via an eco-label. But there was a problem with this that was found by an energy economist that used to be here at Stanford, Sebastian Hood, and he was looking at real-world market data in people's purchases of refrigerators and found that there was a subset of people, about 25% of individuals, who seemed like they were making a binary decision on energy efficiency based on the presence or absence of the label. And the problem with this was there's such a wide range of efficiencies that are captured by the Energy Star label that a lot of people might have been underinvesting in energy efficiency compared to if the label wasn't there, and we might have actually been creating some inefficiency. So we utilize eco-labeling in the hopes that for people who are able to and willing to parse complex, concrete energy consumption data, they're actually going to focus on that data more when they see the label. And for people who don't have that desire or that capacity to go through the numbers, that it'll act as an informational substitute. So this kind of motivated us to look at, in what types of individuals might the Energy Star label actually be backfiring, who might be over or under investing in energy efficiency independent of the label, and who's most influenced by the Energy Star label. So we did a nationwide survey of 1,550 households. Everyone had purchased or remodeled their home in the last 5 years. And we asked them a series of stated choice tasks you'll see in a minute. We elicited consumer decisions on fridges and bulbs, specifically compact fluorescent light bulbs. And so here's an example of what people saw when they were making decisions on light bulbs. We had 4 factors for bulbs. We had 6 for fridges, but we were mainly concerned with presence or absence of the Energy Star label, the energy consumption of the product, and the price, and the trade-offs that people made between those 3 attributes. And people basically just chose between 3 items, and they did this 10 times for each product category. We also gave them a number of different questionnaires to capture the kitchen sink, everything from demographics to financial history to time preferences, environmental attitudes. We gave them math tests to capture how good they were at math, and personality traits. They loved us by the time that they were done with this questionnaire, I'm sure. And so I'll give you an example of how we elicited people's discount rates, for instance. It was just 21 questions that were variations on, would you prefer $30 tonight or $35 in 20 days? And that gave us an ability to calculate how steeply somebody discounts the value of money through time. So we started assessing, how large is the gap between a rational benchmark of how people should value energy efficiency and the actual decisions that people were making. So who were undervaluing or overvaluing energy efficiency. And the benchmark was an economically rational benchmark of basically what's the break-even point? Are you willing to pay enough that for a reduction in energy cost that it breaks even with the amount that would have cost you over the lifetime of that product? And we gave people the average lifespan of the bulb and the cost per kilowatt hour extended and all of those different things so that if they were economically rational actors, they could calculate this in its entirety. And of course, given no one is actually going to do this in the way that they operate. But economists would think that they might. So, so we're focusing on results. We were able to calculate models in two different ways. One using a standard 6% discount rate for everyone, or we could tailor it to the individual and use their own discount rate. And we're only going to talk about results that were significant in both models, remained significant after a bond for owner correction. We had so many different variables in this that we had to account for 16 hypotheses, and things that were significant in models that both included and excluded environmental externalities. So the cost per person of the environmental harm that was happening just by using these appliances. And we get tables like this, which I'm not going to belabor you with, but we're just going to run through the take-home messages, which is highly pro-environmental people overvalued savings on energy consumption. Now, I put that in quotes because we're not capturing the warm glow that they might be feeling by buying pro-environmental things or the social gain that they think they might get if people see that they have an Energy Star label on the fridge that they got in their house or any of those things. The surprising thing was that highly numerate people systematically undervalued savings on energy consumption. And we're going to revisit that in a minute because this was just looking at who's undervaluing and overvaluing, not the magnitude of how far off they are from rationality. If you look at who's closest to rationality and what accounts for that disparity, then we actually see, again, people that are way far off from rationality are the people who are good at math. The people who are more rational are, in general, women, higher household income, and have a graduate degree. So why the highly numerate? So there's some examples where people who are good at math can pick a worse option when that option includes more numeric content. So it basically makes it more attractive to them, and they put greater weight on it. So they may extract more emotional content from numbers. And this may also make them more price sensitive, which would reduce willingness to pay across all the different attributes. They might become penny wise and pound foolish. So I've been doing a study, which I'm still analyzing the results from, that follows up on this, where we ask a bunch of thrift, penny wise, pound foolish questions. And also I try to disrupt people's mathematical abilities while they're doing the stated choice task in an effort to try to see whether being good at math is just highly correlated with a personality trait that makes you thrifty, or whether it's actually some role of numeracy itself. So we can see the effect of the label on people's valuation. To break this down, basically everyone on the bottom row increases their willingness to pay for energy efficiency if the label is present. Everyone on the top row is decreasing in reaction. And people on the left started out in a place where they were already overvaluing energy efficiency, people on the right where they were undervaluing. And people that are in group D are basically, it's mostly people that are pro-environmental, have very strong pro-environmental attitudes, and basically they just become overshooting more and more in how they value energy efficiency. But we're also helping a lot of people who started out in a place of undervaluation to be more rational through the use of the Energy Star. And you might think that people who are good at math don't necessarily, wouldn't respond as well to something like a label, which isn't full of concrete information. But you can see that actually it worked better on people who were good at math in terms of bringing their valuation up than it did for the general populace. So that kind of sets the stage for the neuroimaging that we did. And what we wanted to ask is, what are the neural and product attribute-driven mechanisms that might be motivating people's purchasing choices? And how does this differ in people who have high or low pro-environmental attitudes or math skills? Because we know that's relevant for these under and overvaluation. And do the discount rates also play a role in how people think? So we gave 36 people $10 that we endowed them with. Again, another incentive-compatible task where they were buying CFLs while we were scanning their brains, which I'm sure was riveting because we gave them 64 to go through. And they also did the full nationwide stated choice survey and questionnaires. And we discounted these CFLs 75% while we were basically trying to promote giving. And this elicited trying to promote purchasing. So this elicited a purchase rate of about 38%. We wanted to have enough data to analyze, essentially. And people essentially saw this information presented piecemeal. Every 4 seconds, we would add a new attribute. So first, they saw the light bulb, then Energy Star label or not. We had a dark blue box if it wasn't there. The annual energy cost to them, and then the price, and then they were able to pick yes or no whether or not they wanted to buy it. And just to refresh on brain areas really quickly, we're going to be focusing again on these affective systems. For positive arousal, we're looking in the striatum, particularly the nucleus accumbens. For negative arousal, we're looking at the anterior insula. And for integrating information, we're looking at the MPFC. We're going to add one more region. It's a little hard to see here, the distinction between the red and pink, but pink is nucleus accumbens, and then slightly above there is the caudate. For our purposes today, we can think of it still as part of that reward pathway. It's part of the striatum, still associated with positive arousal. It's a little bit more on the side of action planning than calculating reward magnitude and that sort of thing, but very closely tied in operation to the nucleus accumbens. So what predicted purchasing? Both the areas of the striatum, the caudate and the nucleus accumbens, positively predicted that people would buy these bulbs. Each responded positively to lower prices, but also to the presence of the Energy Star label. Nucleus accumbens was significantly more active when the label was there versus not. And there was also a marginal difference between conditions when the label was there or not, if the price was high versus low, and it favored a lower price. For the caudate, very similar, more significant difference between the label being there or not, and also a significant difference when the label wasn't there between low and high prices. We also saw activity in the MPFC, again, subjective value calculation, and this was correlating with people considering the interactions between price and the label, and also between all three product attributes. It's very, very common in purchasing studies integrating information for this activity to correlate with buying. But as we saw, similar to the other study, the MPFC activation was actually associated with fewer CFL purchases. And what this might mean is because it's evaluating trade-offs in this region, the more difficult trade-offs may require more horsepower, but ultimately not elicit purchases when people are on the fence. And we'll see also that it's really related to individual differences in a moment. This is just a different way of looking kind of at the trends between brain activity and purchasing behavior. Every one of these dots is a different item that they saw, a different CFL bulb. On the y-axis, we're seeing the probability that that item was purchased across the group. And on the x-axis, for the different regions, we're seeing how active was that average brain activity at the time that people were making the decision. And we see the areas associated with positive emotions are positively associated with buying, negative emotions negatively associated, but also cost-benefit assessment is negatively associated with buying. Again, just a logistic regression to kind of summarize that we've got nucleus accumbens and the MPFC working at odds with each other. Nucleus accumbens and caudate track together, so I took caudate out of this, but if we put caudate in, then caudate plays the same role as the nucleus accumbens in these models. So what about actually looking at and breaking down individual differences? Let's look at pro-environmental attitudes first. There's differential response in the caudate based on the interactions of price and the Energy Star label, based on people's pro-environmental concern. And the way that breaks down, now this is bar graphs where we're basically sampling out of the entire caudate on both sides, and if we look there, it's a very specific subregion that is different between these two. So it's not going to look as profound in this, but what we can get out of this is basically the people who are low in their pro-environmental concern are responding in the reward pathway most to the price differential, and only look at Energy Star label, only react to the Energy Star label when they're differentiating between high-priced items. And in people that have high pro-environmental concern, they're focusing a lot more equally on the Energy Star and price. For people looking at people's numeracy, it was a little bit harder to distinguish numeracy effects because everybody in Silicon Valley is really good at math. So you can see on the top is basically our histogram of people's scores, the distribution of scores out of 15 for the national sample. And then at the bottom, it's our local sample of people in Palo Alto. And we had one person basically who was under the mean for the national sample. And the range was a lot less, so standard deviation was reduced. It hurts our ability to really take apart that we didn't pick up the willingness to pay for energy consumption being different in this sample. However, numeracy overall was significant in people not buying. So this plays into that thrifty mechanism that we were talking about earlier. People that are good at math are just less likely to buy. And this might be that affect towards numbers. And we actually do see that the caudate is more active in these more numerate individuals when they see low prices. So instead of a pain of paying idea, it might be that they get a reward signal out of getting a good deal. There's also like a lot of nuance in how the affective systems in people who are highly numerate respond to energy costs. So while they behave similarly across everyone in the caudate, when they're looking at high energy costs, the caudate is responding a lot more to low energy costs in people who are good at math. The people that are bad at math are really responding based on price differential. In the insula, where we're dealing with negative arousal, you actually get a polarizing effect for high annual energy costs. So people who are bad at math, when they see high annual energy costs, the insula goes way up. When people who are good at math see them, it's tamped down. Okay? And this might be, we're looking at brain activity when people have already seen the energy cost and then they see the price. So they might have already decided if it's a high annual energy cost item that they're not going to buy it, and thus they've stopped evaluating it basically, and maybe affect is playing less of a role because their attention's elsewhere. But basically, numeracy is related to this differential affective response, and there's some symmetry in the way the positive and negative systems are looking at energy cost. The last thing we want to look at is discount rates. And we're incorporating discount rates because it's well studied in neuroeconomics. We know where to look for how people trade off reward magnitudes that are immediate and long-term gains, that sort of thing. And there may be some parallels between how people trade off the short-term and long-term rewards and trade off upfront cost and annual operating cost. So energy economists also often attribute that underinvestment in energy efficiency to these high, people having high discount rates. So this is what motivated us to look at this. And we actually do find that people with high discount rates, when they see the Energy Star label, when that first appears to them, they have a very different response. All the affective systems in the MPFC have an elevated response in people who have high discounting. Now, here's the really crazy thing that we found, which is really that discount rates actually capture such different modes of thinking about these trade-offs that different brain regions predict behavior depending on your discount rate. So people that are high discounters actually have significantly more activation when in these affective systems. So these regions are actually predicting purchasing behavior more accurately in them. The nucleus accumbens is driving purchasing, and the anterior insula is making them not buy. However, for people who are low discounters, they're actually using just the MPFC, and that is driving down their decision to donate. So it's really two different processing styles, being emotional or rational about parsing this information. You can also see that in general, there's more significant z-scores on the interaction terms for people that have low discounting. So they're integrating information more deeply. They're considering those interactions and those trade-offs a lot more, as would make sense if they are relying more on the MPFC to make those decisions. So though high and low discounters are using different mental machinery, they do converge on similar behaviors. The buy rates are about the same for both groups. But this gives us some indication of knowing how we can know how to provide environmental messaging to create the biggest impact, because we know which systems are being leveraged in which groups, and if we want to focus, say, more on high discounters, we know that things like the label are working on their reward pathways, and they're using those to make decisions more readily, and so we can kind of hand tailor these things. So what did we learn overall on this? The reward pathway in individuals with low environmental concern primarily responds to favorable pricing, while people that really care about the environment are giving more equal weight to the Energy Star label being there and the price. High numeracy gives rise to differential emotional responses to price and operating costs. And individuals with high discount rates respond more emotionally to the Energy Star label and are driven more strongly by those emotional systems during processing. So future directions that I want to head are understanding this undervaluation effect in high numeracy, figuring out whether it's correlated with numeracy or it's actually part of numeracy itself, and whether it's related to people being thrifty overall and just buying less, or to the actual energy efficiency. And then looking a little bit deeper at the relationship between temporal discounting and these trade-offs in price versus operating costs. Ultimately, I'd like to predict real-world market data in these energy-efficient appliance purchasing behavior using the brain response during fMRI. And going back to environmental philanthropy, I'm hoping to work with Nature Conservancy in the coming months to do a similar population-level prediction study where we use real-world conservation campaigns that they're carrying out for different areas, and show them to people in the magnet, get their responses, and see if the brain responses, say the nucleus accumbens, can actually predict which ones get funded and how well they get funded. And I'd really like to kind of keep working on trying to obtain a value signal from the brain which complements these contingent valuation methods, because we found that people weren't focusing on the resource itself for making those decisions, but if we can elicit some kind of value signal that's associated with the resource, that would be really powerful complement to contingent valuation to kind of shore up all those opt-out responses, those protest zeros that we're seeing. And I'd also like to look at how sense of place and environmental education can translate into this visible brain activity that we see based on people being more pro-environmental, and then downstream of that, how that influences pro-environmental behavior. So these are the first steps in environmental neuroeconomics. I think since we've started showing that these methods do provide some insights that you can't get anywhere else, especially, for example, the discounting is a good example of that, where people are converging on similar behavior, but they're using very different neural mechanisms to get there, which you can leverage in different ways in different people. I think more people are going to be working in this field. We've gotten a lot of attention and a lot of interest all across the country, and I'm hearing about more and more people wanting to work on applying neuroscience to environmental issues. We want to find some new applications for this and try to prove that these insights in the brain translate to the broader population, that you can scale these studies so that you can actually predict that population level behavior. And then harnessing the insights that we find, especially with regards to individual differences, to kind of create better tailored policies, figure out ways to optimize across all these different groups of people, different groups of thinking, to try to combat climate change and get a better world for all of us. So, yeah, thanks everyone. Do we want to do questions or acknowledgements?
About 15 minutes, 10, 15 minutes for questions.
Okay.
So thanks for your talk, Nick. That was really great. One of the things I'm wondering about is, can you look at, or do people ever look at different demographics of the people that you're neuroimaging to see if those things are also playing into their emotional response and their propensity to give to an environmental cause, or that sort of thing, like race or economics?
Yeah, so there's some cultural neuroscience stuff that's started now, where it's viewing differences between different ethnicities and that sort of thing in terms of how they respond to everything from even how they react to different types of smiles and that kind of thing. Not a lot. I mean, there's really nothing. There's hardly anything on environment at large in neuroscience right now. But age is a tricky one to get at because the older people get, the more idiosyncratic their brain is laid out like. And so when you're trying to average everyone's brains together, it's a little more dodgy, and you're having to warp it more if they're older. So we kind of limit it to 40s and under, right? Which is bad, unless we're explicitly studying age, in which case you account for it. Yeah. Yeah.
Thank you, Nick. Amazing research. You mentioned sense of place in the willingness to pay. I was wondering what you know at this point about that property, which is really interesting for people that study the allocation of conservation funding to purchase land for conservation, for instance. There's research that shows that there's a difference between what would be optimal for certain species and where money is actually allocated.
Right.
So what, for example, in your study of the parks, were people more interested in the parks that were closed?
Yeah, so there was a very high correlation between what they thought was iconic and what they thought was familiar and had visited. For obvious reasons, if you've got a few standout parks, people are more likely to visit them. But one of the interesting things was you got not only this reward pathway activation being stronger for iconic parks, but also in a part of the brain that encodes spatial landscapes. So that was more vibrantly active when people found it more iconic. And I also looked at just the familiarity score that people had for that place as opposed to iconicness. And that had basically the same results. So I think looking at the interplay between the reward pathway and parts of the brain that encode spatial landscapes is where to look for sense of place and where I would start looking. Yeah. Oh, yeah.
Have you done any kind of studies where you've done counting what the contributions were when you modified the counting so you actually get the results? Has that been done?
Not yet. To-do list.
That would give you a clearer understanding how you can change, make lots of changes to the
Yeah, so it's like a few steps out. It's basically, try to do it in the lab, try to do it to predict population level, and then start intervening, right? Making interventions based on that and see if you can modify the policy. Yeah. Fran?
Something I always wonder, first of all, thanks so much for this great presentation, but something I always wonder with these contingent valuation questions is this problem of collective action. So you're kind of being asked, you want to give kind of $10 to save the whales or something, right? But saving the whales doesn't just depend on my $10, it's going to depend on what everyone else does. And I think, the same thing is with the way the questions in your talk study. So I'm wondering, how do you think this comes into, what you see in the brain and how are people doing that calculation?
Yeah, so I think, so that comes back to like environmental locus of control and how much self-efficacy you feel you have to impact something with your contribution. We did basically tell people beforehand, your contribution is in concert with the contributions of a lot of other people. It's not like standalone. Don't think $18 is going to save, this park, right? So we made that very clear to people to try to put them in a frame that they're part of a collective. And they did have, social cognition and theory of mind regions were online when they were doing this stuff. But I think the MPFC activation that's telling you to keep the money for yourself, I think that's actually people probably doing the weighting and figuring out it's $15, it's not going to do anything, and the more they think about that, the more likely they are to perseverate on that given trial, the less likely they are to actually act, right? So overthinking it and talking yourself out of it, yeah.
So, great presentation, thank you very much. So the question I have is, how long do you expose the subjects in the FNMR to the scenarios?
They're pretty fast scenarios because you don't want to you're averaging the activation over the course of when they saw that time period, right? So you don't want to give them 10 seconds, read a paragraph or something like that. The trials on average, you're feeding them a new piece of information every 4 seconds, and so the whole trial maybe 15 to 22 seconds for that range, and then you're doing anywhere from 40 to 75 trials, depending on the thing.
I think time for one more question. If not, let's just thank you.
Yeah. I also just wanted to thank my committee. So Brian, you've been carrying me through all this and teaching me all the neuroeconomics behind being able to pull this off. And Nicole, you've been so great at teaching me how to think about environmental behavior from not just the psychology perspective, but a wider one. And Robert, you've helped me through probably going on 10 years now from undergrad, just figuring out how to navigate academia and public talks and all that fun stuff. And Ursula, you've been really insightful for environmental risk perception studies, which I wasn't able to talk about today, but is something I'm going to be working on in the coming months, and it's something I teach heavily out of when I teach my own class. And Paul, thanks for stepping up to be the chair, and all the classes on judgment and decision making I took from you over the years. A couple more, and then I'll let you guys go. Really wanted to thank my parents. I've had a lot of help to get here from everyone, obviously, but I've had over 80 broken bones in the course of my life, so they've helped me through a lot of rough stuff. And really wanted to thank also my colleague on the Energy Star work, Ansu Sahu. It was a really productive collaboration, and he really shored up the econometric side of the methodology and the work. The E-IPER community, everyone in my cohort, my fellow PhD students, and the staff, faculty from pre-court and from IPER, and even from my undergrad, everyone at Brian's SPAN lab, especially all of the lab managers through the years have helped me a lot with data analysis. And then there have been a lot of different groups. Woods Institute Rising Environmental Leaders Program, the Center on Philanthropy and Civil Society, the Haas Center, and the Center for Ethics and Society have all given me different communities to talk about this work with, different perspectives, and people to bounce ideas off of. That gives me a much different view on especially the moral and ethical implications of these environmental issues that we're studying. The Precourt Energy Efficiency Center funded a lot of the research that I've done, and actually is helping me do a postdoc after this. And then I had a lot of great research assistants too, helping with the nuts and bolts of things. So, thanks everybody.